In this video, I'm going to introduce the assignment for week 11 on exploring the file system. So for week 11, we're going to talk about streams and file system access. And for the homework assignment, we're going to build something that essentially explores the file system by reading information about files on your computer. It's broken down into 3 parts, and I have examples of each part of the code that you're going to have to implement. While check path is a good program to look at to show you how to do part 1. File attribute lookup is a good program to look up to see how to do part 2. And list_dir is a perfectly good example of how you could do part of step 3. And finally, I have some other demos in here, such as checking if a file exists or not, which you're also going to have to do. So for this homework, we're just going to have to glue together some of these pieces of code that I've already shown you and I have examples for. So what is part 1? For part 1, you're going to create a new class, and it's going to have a public static void main method on it, and you're going to run it directly. The part 1 is going to prompt a user for a file path, and we're going to save this input and check whether or not a file exists under this path. First though, you're going to check if the file path is valid. You can have an invalid file path on Windows if you have something like a $sign in it, or I believe a comma is also invalid on Windows. There are certain characters that are invalid files on Windows. So you're going to check if the file path is valid. And secondly, you're going to check if a file exists at that file path that you had the user enter. And if it does exist, you're going to print to the console and say it exists. And then you'll be able to go to step 2. So step 2 is predicated on the fact that you should have a file that is valid and exists. If you don't, you need to repeat step 1 because we can't go any farther until you have a valid existing file path. Because the next thing we're going to do is call basic file attributes using this file.read attributes. So for part 1, I have an example of having a while loop, and we are checking with a path and we're making sure that it's valid. If it's not valid, this flag will be set false, so it'll never get past the while loop. This is a pretty easy way to do a while check, and we can also check if the file exists. So this whole block of code here is checking not only if a file is valid in terms of the path, but it also exists. And the reason we know the file path is valid is because this path got successfully defined here, and it did not throw an exception. If it threw an exception, we would have gone to the next block in the while loop, or the next iteration in the while loop, and we would have had to start all over again. Because if a file path is not valid, it'll throw an invalid path exception. So going back to the homework, for part 2, we're going to read this basic file attributes object using files.read attributes. And this is also a fairly simple operation. Once you have a valid file path and you have a file that exists, you can simply call files.read attributes, and files is in java.nio.file.files, and you're just going to be able to call read attributes, and you pass in the file path followed by basic file attributes.class, which tells you which type of file attributes class to return. On this basic file attributes object, you're going to have something called isDirectory, which we're going to need, isRegularFile, which just means is that it's a normal file and it's not a link. IsASymbolic link checks if it is a symlink. Creation time gives you a timestamp, and last modified time also gives you a timestamp. So you can tell all kinds of information about a file, including the size. There are other things on this attributes object that I did not show in the example here. But this is essentially what you're going to do for part 2. So part 2 is pretty straightforward, and I have a list of all the things that I want you to print out. So print out the file name, print out the full path of the file, print out the size of the file, and you can format that in megabytes or kilobytes if you would like. You can print out, is the file a directory or is it a normal file? When was it created and when was it modified? And now in the last part of part 2, we're going to make sure that this is a directory. If it was not a directory, you're going to make the user repeat part 1 and part 2. So going back here, we can say is directory. That's just a Boolean. And if it's not a directory, the user needs to keep entering a file path until they get a directory. Because for part 3, the user needs to have a directory. So going down to part 3, you're going to list the contents of a directory, and we're going to find some information about what's inside of this directory. And you're going to not do this recursively. You're just going to read the top level of the directory. If you do this recursively, it'll be much more complicated, and it could possibly make your program crash, or it could do all kinds of stuff. And we don't want to go into recursion just for this homework, so this is kind of a more in-depth topic. So all we're going to do is list one level deep. And recursion, if you recall, a recursive function is a function that calls itself. So when I say don't do this recursively, it means if you have a folder with folders inside of that, that folder might have folders inside of that folder, and one of those folders could have folders inside of those. So you could get very deep into the file system exploring it, and you might explore thousands of files if you list the wrong directory for this. So we don't want to do that. We just want to list one level deep. We don't want to do this recursively. And I've had a lot of students in the past turn in recursive versions of this, so you do not need to do this. Just do it one level deep. And here's an example of listing a file, listing the contents of a directory. All you have to do is take the current path and create a directory stream object with path as the generic type in there, and you call files.newDirectoryStream and pass the path in there, and you'll get a list of paths. Now this is a collection object, so you can iterate over it, and you can do for path and paths. Now at this point in the course we haven't done collections yet, but you could think of this like an array that sizes dynamically. And what it's going to let you do is pass it into a loop like this, a for loop, so that you can iterate over each of the paths that are returned in this directory stream. And what we're going to do with these paths is we're just going to loop over all of the paths in the directory and print out the names. And we're also going to do some other stuff while we're doing this loop. So the other things that I want you to do in here are to count how many plain files are in there, and that should be easy to do because all you have to do is grab the basic file attributes and say is a regular file. Secondly, I want you to count how many directories inside of here, which is also fairly straightforward to do. You just grab the file attributes and then you say is a directory, and you'll be able to put a variable up here above the loop and say number of directories equals 0, and every time you see a directory you say number of directories plus plus. You'll also be able to say what is the most recently created file in the directory and what is the oldest file in the directory. And you should also be able to do that because we're going to have created timestamps and modified timestamps, and you'll be able to compare it to see what is the highest and what is the lowest while you're looping. And at the end of the loop you'll be able to print those out. So that's all there is for this homework. It may seem like a lot, but it'll go pretty fast because all of these build on top of each other, and you have demos showing you how to do kind of each of these steps here. And what I'm going to do here is I'm going to give you a starting point to this program. I'm not going to call it homework week 11. I'm going to call it something else, exploring the file system homework start. So we'll create a new class with the main method, and I'm going to create a scanner at the top level. Okay, so now we have a scanner, and I'm going to create two methods, or actually we'll create three methods: public, static, string. Actually, this should be a path. Part 1. That's a Java NIO file path, and then I'll say public static this will be a void, and it'll be part2. And the difference here is that we're going to get a file path in part1, and then in part2 we're going to pass it a file path. So we'll give that a look, and we'll pass it a file path. And then for part3, we're going to be able to take that same file path that we got from part1 and pass it in there to solve our problem here. So what you'll do is something like have a path from part1, and then you'll be able to call part2, and then you'll be able to call part3 with the path. And I believe in part2 you're going to have a check to see if it's a folder or not, and you might even be able to say boolean is a dir for part2, and if it's not a dir, you can probably repeat part1. So you'll have to do some kind of logic around that. So return So you'll do some logic to repeat part1 if we did not get a dir, and you might even have to put both of these in a while loop. So you might say boolean valid, or sorry, is a dir equals false, while not is a dir, and you can run both of these pieces of code right here in this loop. So that would be a good way to repeat the logic here in case you fail and you do not get the user to enter a valid folder. So here we go, path equals null, just so we can define it up here, and then part3 will have access to that, and you won't terminate the while loop until you have a valid valid result from that. And so in here you'll put the logic for part1, and here you'll put the logic for part2, and finally here you'll put the part3 logic. And at this point you should have a valid existing directory file path. So this is just a quick introduction to the homework, and I have an outline here for you. I'll post this up on GitHub, and we will go over this in class as well. Thanks for watching.